P1.2, specific charge. I've included this as a video in its own right, although it's very short, because specific charge is something that quite often seems to come up on exam papers, and because it's not very complicated and doesn't take long to teach, it's quite easy to forget about it when you're revising. So the definition of specific charge is it's the charge of a particle divided by the mass of the particle. Nice and simple. The units are coulombs per kilogram. So coulombs for charge, kilograms for mass. If we start with a couple of fundamental particles, such as a proton, so that's represented by the circle here, and charge is a bit difficult to represent, but I'll represent it by this sort of red sparkle here. So if we do the calculation, we've got charge on top. Charge is the charge on a proton, 1.6 times 10 to the minus 19 coulombs, same as an electron, but positive. And if you look up the mass of a proton in the formula sheet, it's this, 1.67 times 10 to the minus 27 kilograms. Once you've got that, all you've got to do is put that into your calculator, and the answer is 9.58 times 10 to the 7 coulombs per kilogram. If we do the same for an electron, electron is much smaller, so I've represented it by a smaller circle, but it's got the same charge, although it's negative, so I've tried to draw a sort of equal sized sparkle here, just blue, to represent a different sign. And if we do the same process again, we've got the same charge on top, 1.6 times 10 to the minus 19, don't worry too much about the sign. And if we look at the mass of an electron, it's 9.11 times 10 to the minus 31 kilograms. So, again, in our calculators, gives us 1.76 times 10 to the 11 coulombs per kilogram. Much bigger, you'll notice, 10 to the 11, than the proton, which is 10 to the 7. And this number here is actually the highest value of any particle for the specific charge. The electron has got a lot of charge concentrated in a tiny, tiny mass, and it's sort of the most densely charged particle that we know of. So you're often asked to work out the specific charge for other particles. For example, on page 5, question 3 of the textbook, they give you a copper atom. So we've got the information that it's got 29 protons and 63 nucleons, and it loses 2 electrons and becomes an ion. So the first part of the question says, what's the charge in coulombs? Now be careful, because it's not 29 units worth of charge. A normal atom has equal numbers of electrons and protons, so the copper atom would normally have 29 protons but also 29 electrons. This one happens to have lost 2 electrons, so it's going to have a charge equivalent to 2 electrons worth, but positive. So 2 lots of 1.6 times 10 to the minus 19 coulombs, which comes to 3.2 times 10 to the minus 19 coulombs. So it's just the unbalanced charge. The second part of the question asks for the number of nucleons. Well, that's quite easy because it's just the mass number at the top here. So that's 63. And then the third part of the question asks for the specific charge of this particular ion. So we have to put its charge on the top. And on the bottom, we multiply the number of nucleons by the mass of each one. So neutrons and protons are pretty much the same mass. 1.67 times 10 to the minus 27 kilograms. And calculator once again gives us the answer, 3.0 times 10 to the 6 coulombs per kilogram. So if you get this type of question, obviously pay attention to the number of protons here, but look out for the information about how to work out what the unbalanced charge is. And remember, your mass number, you need to use the nucleon number at the top. Okay, so practice a few of those.